Hi everyone, welcome back to the series of problem solving. So in last couple of videos we were learning two pointers pattern and we were seeing this problem where we are given a sorted array and a target sum, and out of this sorted array we have to find distinct elements whose sum is equal to the target sum. So we saw three approaches for solving this problem. One is brute force approach, the other one is two pointers pattern approach, and the third one was hash map based approach. So in this video I just wanted to tell you what time and space complexity for each algorithm would be, and I wanted to just compare these algorithms and provide you tell you when to use which approach to solve this problem. So let's get started with the very first approach, that is brute force based approach, right? So in this approach what we are doing is basically this is the sorted array that we are given. So in that sorted array what we do is we start from the first element, loop through each and every other element and check that if the sum is equal to target sum, then we return that element, else we do for the second element, loop through all the other elements and continue in this way. So basically if you think, then what we are doing is for each element we are looping through the array, looping through entire array, which means that if my size of the array is n, then for each element I am doing n computations, and so for n elements my total computations would be n square. So my time complexity, which means that time taken by my algorithm, like the change in the time taken by algorithm will grow n square times as my size of the input array increases. So basically time complexity of brute force approach would be O of n square. Now what would be the space complexity? So over here you can see that in this approach we are not using any extra space. What I mean by extra space is that we are not considering the little variables that we use, right? So we are not using any extra space, as in like if my size of the array increases, the space utilization in this algorithm will not increase. Whatever earlier space that was used, so if my size of the array is 10, then the space utilized would extra space utilized would be same when my size of the array is 100 or 1000, right? So I am not using any extra space over here, so that's why in brute force approach we have a time complexity of O of 1. Now let's discuss what will happen in case of two pointers pattern. So as we are given a sorted array, we are able to use this two pointers pattern approach. So in this approach basically we have two pointers and basically we saw in approach that these two pointers move towards each other to find a target sum, and in the end, in worst case, both the pointers will cross each other. So when will this happen? So when there is no pair in this array with sum equal to target sum, in that case both the pointers will cross each other. So what would be the time complexity? So if you see over here, the entire array, let's say of size n, is only visited, means it is looped through, we are looping through this entire array only once. Okay, so if my size of array is n, then I am doing only n computations. So what would be my time complexity? It would be O of n. Okay, now also even in this approach we are not using any extra space. We are not using our extra space is not growing with the size of input. We are using constant space, so our space complexity would be O of 1. Okay, so that's about two pointers pattern. I told you that we can use two pointers pattern because we are told that our input array is already sorted. But what would happen if my input array is not sorted, and what if I want to use this two pointers pattern? So in that case, what you would have to do is you would have to sort array first, and then you have to apply this 2 pointers pattern. Okay, so the best possible, like the good algorithms like merge sort, quick sort provide, in worst case, provide you the time complexity of O of n log n for sorting an array. Okay, and then on top of this, for applying this 2 pointers pattern, as we saw in this case, we have time complexity of O of n. So for this we would have O of n time complexity. So this is obviously greater, like it's n times log of n, and this is only n. So for time complexity we always take an upper bound. So out of this two things, this sorting of an array is taking more time. So our time complexity in a case where my array is not sorted and I want to apply this 2 pointers pattern would be O of n log n. Okay, and in this case also I'm not using any extra space, so my space complexity would be O of 1. Okay, so that's about that's regarding like my array is not sorted and I want to use 2 pointers pattern. Now let's see this hash map based approach, right? Oh, sorry, I already wrote this down. Let me erase that. Yeah, so what will happen in case of hash map based approach, right? So in hash map based approach, if you remember, we have array and we visit each and every element. Now if we check, we maintain one hash map which is initially empty, and we check that if my element, if this element, particular this element which I am visiting is already present in this hash map, then that means that my pair is already there, right? You can check out the video where I discuss this approach. So basically in this approach we are maintaining an extra hash map. So over here we would visit the entire each element or the entire array once. So when the worst case will happen, when we don't have any pair with the given target sum, so in that case what would happen is we would visit the entire array, and we are visiting only once. So and if my size of array is n, so my time complexity would be O of n. Now what about space complexity? So as I already told, right, we are visiting each element, and we are, if that element is not present in hash map, we are inserting the alternate element of the pair inside this hash map. So in worst case, all the alternate elements which can make a target sum would be stored in this hash map, right? So the alternate element of this element, second, third, fourth, and so on, for each and every n elements, that they would be stored in this hash map. So in worst case, the size of this hash map will grow to n. Okay, so if I have 100 elements, and in worst case I have to store 100 records or 100 values in this hash map. If the size of the array grows from 100 to 1000, then I would have to store 1000 elements in this hash map. So my extra space that I am using is growing linearly with my size of the array, which means size of the input. So in hash map based approach, I will have O of n space complexity 2. Okay, I hope this explanation is clear. So just last thing that I wanted to tell is that if you see in this hash map based approach, we don't have a requirement that my array should be sorted, right? That was the requirement that we had in this 2 pointers based approach. We didn't have any such requirement in this hash map based approach, because we are already storing the element we require to make the target sum in this hash map, right? So whether my array is sorted or not, this solution will work. So basically, if I am given that my array is not sorted and I want to solve this particular problem, then I have to, apart from the brute force approach, obviously, I have two approaches. One is like you sort the array and then apply two pointers pattern. Then in that case, you would have time complexity of n log n and space of O of 1. So basically, in this case, if you have a space as a concern that you don't want to use more space, then but the time is not a concern for you, then you can use this approach like sorting the array and then applying two pointers pattern. So you will get good space complexity, but you will get little bit bad time complexity, like it's log n times of n, right? But in case where time is a concern for you, like you want your algorithm to perform good with respect to time, and space is not a concern for you, then you can use this hash map based approach where you have to use extra n space, but the time complexity of that algorithm will be little bit good. That would be O of n. Okay, so that is all I wanted to tell about all these approaches and this problem. So that is it about this theoretical lessons. So see you all out in coding playground. See you there.